Hi everyone! This video looks at a strong base titrated with a strong acid. Our focus will be on the initial pH when 0 mils of titrant have been added. Because the titrant is at 0 mils and no reaction has occurred yet between the base and the titrant, we do not need a millimole table. This situation is what we call initial pH. Here, we can use the molarity of the base given in the problem for our hydroxide concentration. From there, we can calculate pOH by taking the negative log of the hydroxide molarity. Then, recognizing that pH plus pOH equals 14, we can rearrange that equation to solve for pH by taking 14 minus pOH. The 14 is not exact because it comes from the autoionization constant of water, Kw. Using the value of Kw to 2 sig figs will give us 2 decimal places in our value of 14. In our example, we see that the titrant volume is at 0 milliliters, which means we do not need a millimole table. So to calculate the pH, we're going to start by noting our hydroxide ion concentration, which is 0.2500 molar, the original molarity given in the problem. We'll then calculate pOH, which is negative log of the OH, or negative log of 0.2500. We typically don't include the units within the log term because you can't take the log of a unit. Looking at sig figs, remember that the rules for logs are different than what we're used to. If we have 4 sig figs in our value, it means our result will get rounded to 4 decimal places. So doing the math, taking the negative log of 0.2500, we end up with a pOH of 0.6021. And then to calculate pH, we have 14.00 minus 0.6021. Just another comment about sig figs. This is a subtraction, so our sig figs are going to follow the fewest decimal places. Remember, the 14 is not exact. It has 2 decimal places, which is the fewest number because our pOH had 4 decimal places. So our final result will be rounded to 2 decimal places. 14 minus 0.6021 gives us 13.40, and that is our pH.